Right, pre-calculus. Well, we start off here by describing the subsets of real numbers. And of course, we got real numbers, and then we can have rational numbers and irrational numbers and integers and whole numbers and natural numbers. And hopefully you've got a feel for what those are. I'm not going to describe that here in this exercise. And then we talk about how we're going to define it. How can we express it? And one of the ways that we can use is what is called set builder notation. And we're asked here to describe these three sets of numbers using set builder notation. So let's look at this first one. Well, I got 1, 2, 3, 4, 5, dot, 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 meaning it's going to go on out to infinity. But I'm asked to do it in set builder notation. So let's see. I draw a little bracket, and we've got x. Then I come with a straight line, and this straight line right here means such that. X such that, let's see. Well, we start at 1. We got 1, 2, 3, 4, 5. We got counting numbers. So they are natural numbers. So we could say x such that x is greater than or equal to 1, and then is an element, and we draw this E-shaped figure. That's pretty sloppy, but it'll work, as an element of natural numbers. That's an n, trying to be a fancy type n right there. Natural numbers. Well, let's see our second example. X is less than or equal to 3. Well, that could be that could be negative 3. X is less than or equal to negative 3. Well, that could be negative 3, negative 4, but it also could be negative 3.1, 4.5. It could be anything as long as it's less than or equal to negative 3. So again, I'm going to draw a little bracket because I'm doing it in set builder notation. X such that x is less than or equal to negative 3, and x is an element. In this case, it would be all real numbers because it could be anything. All right, the last one, all multiples of pi. So any number, integer, any integer multiplied, pi multiplied by any integer. Actually, that's what that would mean. All multiples of 5. So I'm drawing my little bracket, doing set builder notation. X such that x is n, any number, times pi, and x is an element of all z integers. Close my bracket. All right, well, there's 3 little examples of describing a set of numbers using set builder notation.